So, we are going to talk now about a type of series that occurs very often, and it's called a telescoping series. And it's called a telescoping series because if you've ever seen like the little pirate telescopes that like open up, like they expand and contract, uh, these series expand and contract. Like you start off with this infinite thing, and then things cancel and stuff gets better. Basically, is a nice way to describe it. So I'm gonna go into writing mode, and you'll see like why do we call these telescoping series. I guess let's write that down. So why are they called telescoping series? Because the terms expand out and then cancel and contract. Sort of like how you can open up the pirate little telescope and then fold it back in and it gets smaller magically. I'm not sure who named it, but if you get what I'm talking about, then like it gives you a vague idea of like where it came from, and you'll see it sort of makes sense. So we're gonna look at the sum sigma n equals 1 to infinity of 1 over n times n plus 1. Yes. Now, do you all remember partial fraction decomposition, right? You look at that term, you get the 1 over n times n plus 1. That can be rewritten as a over n plus b over n plus 1. Do you remember how we split up the fraction like that? Well, if you were to solve, you would quickly find out that a would be equal to 1, so you'd get 1 over n. And b would be equal to negative 1, so you get 1 over n minus 1 over n plus 1. I'm not going to bother doing it because you remember it was like a lot of work. Just take my word for it. Like if you really doubt me, just go later and do it yourself, and you'll find that this is what you get. Because we only have so much time. Does that sort of make sense? We're just going to skip that part. Just assume that someone has done their due diligence here. Okay, so what that means is that this infinite sum, because you're just rewriting the explicit formula for your sequence, is the sigma n equals 1 to infinity of, in parentheses or brackets, 1 over n minus 1 over n plus 1. Right? If those two are equal to each other, you should just be able to replace the different formulas, right? Okay, now let's plug in some terms. Let's plug in n equals 1. So if n equals 1, you're going to get 1 minus 1 half. Now, what about when you plug in n equals 2? If you plug in n equals 2, you're going to get 1 half minus 1/3. And then you can plug in n equals 3. You're going to get 1/3 minus 1/4, right? Because I'm just plugging in the different n values. And then this goes forever and ever, plus dot, dot, dot. Okay. So if you look at this, you start noticing, like, well, what's going to happen? This minus 1 half and that positive 1 half, you expect them to cancel, right? And if you look at this minus 1/3 and this positive 1/3, you expect them to cancel, right? So you just sort of expect everything to cancel, yes? And then minus this increasingly smaller term over here, right? As you go out further and further and further. So we can't just look at all of this, because we can't just leave this minus 1/4 here, because it keeps going for infinity, right? That minus 1/4 is going to cancel with the positive 1/4 in the next term, and then you'll have a minus 1/5 and so on. So you have to come back to looking at the partial series. Okay, wait, why is that thing like dangling there? I hate when this happens. Like sometimes, like, do you see how the green thing is like moving on the screen? Like it's floating. Oh shit. Okay, there, fine, let's go. Okay, so let's look at S1. S1 will just be 1 minus 1 half, which is 1 half. Right, the first term is 1 half. or sorry, the first partial series, because the first partial series is just the sum of the first term. The first term is 1 minus a half, which is a half. Now, what's S2? S2 is 1 minus a half, which is a half, plus a half minus a third. What is a half minus a third? Crap. So that's out of a sixth, right? So you're going to have 3/6 minus 2/6. So that's going to be a half plus a sixth. So if you make that out of sixth, a 1/2 is 3/6. 3/6 plus a sixth is 4/6, which is 2/3. So S2 is 2/3. Okay, now what about S3? Actually, wait, no, let's redo that. There's a better way to write this. Sorry. I mean, technically that's what it's equal to, but that's not what I really want to show you. I guess what we should notice is that in S2, the minus half and the half cancel, right? That's what's nice about the telescoping series. Because this is a partial series, you can actually do the canceling. Because there's not like an infinite number of terms you're like, oh, have I really canceled them all? So what you end up with is 1 minus a third, which, like, we got that was 2/3, but I really am interested in looking at it as 1 minus a third, just like how we should look at S1 as being 1 minus a half. We don't really care about the fact that it's equal to 2/3. We care about the fact that 2/3 is 1 minus a half. We don't care about the fact that S1 is a half. We care about the fact that it's 1 minus a half. Okay, so I'm going to pause because I know you got to erase stuff. Yeah, so we're going to keep going. You're going to see that there's a pattern. S3 is 1 minus a half plus a half minus a third plus a third minus a fourth. Now you look at this, because it's a partial series, minus half, half cancel, minus third, third cancel, and what are you left with? Oh, that's 1 minus a fourth. Which, 1 minus a fourth is 3/4. But we don't care about the fact that it's 3/4. We care more about the fact that it's 1 minus a fourth. Now, if you look, each of these partial series, they're equal to 1 minus a half, 1 minus a third, 1 minus a fourth. You're like, oh shit, I sense a pattern. The next one will be 1 minus a fifth, and so on. And there's a way to come up with this. If you look, S1 is 1 minus a half, S2 is 1 minus a third, S3 is 1 minus a fourth. So if I was to guess Sn, what would Sn be? 1 minus what? Not 1 over n, because S3 is 1 minus 1/4. You don't plug 3 in there. Yeah, it's 1 minus 1 over n plus 1. And you're like, oh shit, there's my formula for my partial series. And we know, yeah, exactly, it's, oh, you have an oh shit moment. You know that the infinite sum is going to be equal to the limit as n goes to infinity of your formula for your partial series, right? That's why we defined it as that at the beginning. So that means what you're really doing is the limit as n goes to infinity of 1 minus 1 over n plus 1. What happens to that 1 over n plus 1 as n goes to infinity? What happens to the 1 over n plus 1 as n goes to infinity? It goes to what? This term right here. As n goes to infinity, what does that become? 0. So what is your infinite sum going to be equal to? 1. So this telescoping series Well, this 1 over n minus 1 over n plus 1 ends up having its infinite sum equal to 1. Why? Because it's really nice that when it telescopes, when you look at the partial series, you get a bunch of terms canceling. You end up with the first term minus the last term, right? And then you're able to come up with a formula for that, which you can then take the limit of. If you can rewrite something as a telescoping series, you can figure out a formula for your partial series, and then take the limit of that, and then boom, you get your answer. It's a little involved, but it works. So we're going to look at some examples of this. And let's give you how you're going to deal with this. So in a telescoping or scoping series, most of the terms cancel in the partial series, leaving only some of the first and last terms. Sometimes you have only the first and the last, but sometimes like a couple first ones and a couple last ones will be left over. I'll be honest with you, not everything always cancels, but what you basically get is like a majority of them cancel. Okay, so that allows you to come up with a formula for the partial series, and then you can take the limit of it, and you're like, yay, cool, stuff cancels, hooray. So we'll do another example of this. So the whole point is that most of the terms of the partial series cancel. You can then take the limit of it. So example. Let's look at the infinite sum, where n equals 1 to infinity of the cosine of 1 over n minus the cosine of 1 over n plus 1. So let's figure out if it converges. If it converges, what will it converge to? Okay, so what I highly recommend you do is, like, until you get good at this, you just write out the different partial series. So, like, okay, S1 is going to be the cosine of 1 over 1 minus the cosine of half. Hooray, that's something. You're like, okay, well, what's S2? Well, that's going to be the cosine of 1 minus the cosine of half plus the cosine of half minus the cosine of, minus the cosine of a third. So you're like, oh, okay, cool. Minus cosine half, positive cosine half cancels, leaving me with the cosine of 1. And what is the cosine of 1? Shit, that's some horrible number. Never mind, we're just going to call that the cosine of 1. It's not like the cosine of pi or something like that. Yeah, it's pretty crazy how, to be honest, like how all this complicated stuff just collapses, right? Like, you get cosine of 1 minus a cosine of a third. Okay, and you can notice a pattern right away. S1 is cosine of 1 minus cosine of a half. S2 is cosine 1 minus cosine of a third. So you guess, and you're like, Sn is going to be the cosine of 1 minus the cosine of 1 over n plus 1. Yes, it's always one term bigger in this case. That's not always going to happen, but you just look at it and you're like, oh, it's always one bigger. So that means Sn will be cosine 1 minus cosine of 1 over n plus 1. And then you can take the limit. So you're like, okay, S would be equal to the limit as n goes to infinity of the cosine of 1 minus the cosine of 1 over n plus 1. Okay, so cosine of 1 is a constant, so when you take the limit of that, you just get cosine of 1. Cosine is a continuous function, so the limit of the cosine of 1 over n plus 1 will be the same thing as the cosine of the limit as n goes to infinity of 1 over n plus 1. Okay, so what's the limit of 1 over n plus 1? What will that go to? No. As n goes to infinity, what's 1 over n plus 1? 0. So this becomes cosine of 1 minus the cosine of 0. And what's the cosine of 0? It's the cosine of 0. Think of your cosine. Yep. So you get, this is equal to the cosine of 1 minus 1. This is pretty cool. And yeah. So that infinite sum, let's just copy it. Let's use the lasso. Control C. Paste it down here. This infinite limit has as its sum whatever cosine of 1 minus 1 is. Okay, so this is really nice for telescoping series. Or telescoping. I don't know. I feel nice. It feels nicer saying telescoping. Maybe because my mouth is sort of lazy right now. But boom, whatever that decimal is, that's what that adds up to.